Okay, so on our sequences, we've talked about using the pattern to figure out how they go, and then we've also, at the top, we talked about recursive formula, and that gave us the first term, and then it told us what to do, such as subtract 3 every time, or multiply by 1/2 every time. However, no matter what we try to do, which sequence we look at, if I wanted to find the 100th term, I would have to multiply by 1/2 100 times to figure it out. And that would take forever. So what we could do instead is find the explicit formula, which just means we're going to write an equation for the sequence. And so these are the forms that they use for arithmetic and geometric. And most of the time, you're going to be able to use your calculator to match up the equation to the sequence, but I'm going to show you how you could just write it. And if you can remember these, it will help you do a little bit of process of elimination. So, anytime you see this a sub 1 on both formulas, that means that you have to put the first term in your formula, right? This means your first term. First term. And then the D here was your common difference. And then the R is your common ratio. And so we're just going to use this information. I will give you these formulas for this one. So the sequence here says a sub 1 is 3, a sub 2 is 5, a sub 3 is 7, and a sub 4 is 9. We can turn this sequence into a table. So if I write a table x, y, it really means the first term is 3, the second term is 5, the third term is 7, and the fourth term is 9. So that is how I make my table from the sequence. And then I want to use the formula up here. A sub n equals the first term, well my first term is 3, plus n minus 1, that just means the term before, right, times the common difference. So the common difference here, from 3 to 5, I add 2. So my common difference is a positive 2. Now, it usually doesn't look like this. What happens is they would multiply it out. So 2, backwards distributive property here, 2 to the 1 and the n. So I'm going to rewrite this. A sub n equals 3 plus 2 times n is 2n. 2 times negative 1 is negative 2. And then we would just combine like terms. 3 minus 2 is 1. So a sub n equals 2n plus 1. So that's your sequence. And then you can use your calculator to double check that it matches up with your table. Wait, I realized I forgot to turn my calculator on that you can see. So just go ahead and type on your calculator, or you just take my word for it right now. 2n plus 1 is a linear equation. And so if you were to sketch a graph, you should know that it's a positive slope and it starts at 1. So here's 1 and it's going up. Okay, so it's linear. And then we'll look at the calculator when we come back together as a class. Part B, this sequence, a sub 1 is 3, a sub 2 is 6, a sub 3 is 12, and a sub 4 is 24. So again, if I want to make my table, 1 goes to 3, 2 goes to 6, 3 goes to 12, and 4 goes to 24. And this time, if I go from 3 to 6, I am multiplying by 2. and from 6 to 12 times 2. So this is geometric, and we're going to use the formula up here. That says a sub n equals my first term, which is 3, and times the common ratio, which is 2, to the n minus 1 power. And we're going to leave it like that. Now, for both of these, we were asked to find a sub 12. And again, I forgot to turn my calculator on. So what you would do is you would plug 12 in for n. And so here on this one, we could say 2 times 12 plus 1, which is 24 plus 1, and that's 25. So a sub 12 is 25. And on this one, you really want to just use your calculator. So go ahead and type it in. 3 times 2 to the 12 minus 1 power. And let me see if you can get that correct. If you got 6,144, then you typed it in correctly. And if you did not get that number, I will help you with the calculator part when we come together as a class. If you were to graph this one, it would look like a curve. It would go like this. And this is actually an exponential function. And it creates your curve, and this is what we're going to move to when we talk about a different type of function next week.